This comes out of section 9.1, antiderivatives. Okay, so here's three working their way probably from the easiest to the most difficult. First one is a straight polynomial. The derivative is 4x cubed plus 12x squared minus 7, so the antiderivative is going to be x to the 4 plus 4x cubed minus 7x plus a constant. If you're not 100% sure, and this backwards thinking does get lots of us to pause for a moment, as I just did there a second ago, take the derivative. 4x cubed, 12x squared, minus 7, check. I feel good. That's the right answer. Now, this next one. If I start off with a cos x, I know that the derivative of cos is negative sign, so I actually need negative cos x. Now, I need minus sine x, because the derivative of sine x is just cos x. So try differentiating this, and hopefully you'll satisfy yourself that those signs are correct. Now this next one, exponential functions, which are not too bad generally, but with these extra constants up in the exponents makes it a little trickier. I would need an e to the negative x here. I also need a 5. But if I take the derivative of this, I'd have 5e to the negative x times negative 1, and it means that I don't need another negative in there. Now, plus, here I do need an e to the 2x. Derivative of that would be e to the 2x times 2, but I need an 8, so I have 4 here. And then I need my plus a constant. So it is something that takes practice. It does require wrapping your head around the idea of it, but they aren't impossible questions. Now let's try a couple more. Now in this question we're asked to find the antiderivative on the interval from 0 to infinity, and we're given f of x equals 6 over x squared minus 11 over x plus x. Now, even though these first two pieces of this look the same, they are very, very different, because if I go to do the antiderivative, and you may prefer to write this as 6x to the negative 2 minus 11 over x plus x. The reason why I did it for the first one and not for the second one is basically because the first one I'm going to treat it like a power and deal with the power rule and say, well, I need negative 6x to the negative 1. If I differentiate that, I'll get positive 6x to the negative 2. But the second piece is 11 times the natural log of x, because the derivative of natural log is 1 over x. The power rule stuff doesn't work if you just have 1 over x. I don't need an absolute value here because they gave me this nice interval of only positive numbers. Then I need plus x squared over 2. Differentiate that, you get 2x over 2, which is just x, and I need my constant. So a little tricky with that negative exponents and logs business involved, but that's how I would have to approach that one. Now try a second one here. We've got f of x equals negative cosine of 2x plus 7 over x cubed. So similar in some ways, different in another. You may prefer to write this as negative cos 2x plus 7x to the negative 3. Because it is an exponent, you can deal with it like reverse power rule. You got f of x equals. Now, if I try just putting sine of 2x here, the derivative of that would be cos of 2x times 2. So there's a negative problem. There's also a divide by 2 problem. Now, the second piece of that, we have this 7x to the negative 3. Well, the antiderivative of x to the negative 3 is x to the negative 2 over negative 2. So I still have this plus 7 business, and then plus c. You could tidy that up a little bit by saying minus 3.5 x to the negative 2, or minus 7 over 2 x to the negative 2. But that, if you differentiate this function, you'll end up where we started. There was one that I wanted to do with you that looks a little bit different, and at first it looks like it's something we don't have the ability to do yet. 3 plus x to the 4th over x to the 5th. That might initially you might look at that and say, well, that looks like quotient rule or some gross thing because I've got a denominator. But if you just break it into two pieces, you got 3 over x to the 5th plus x to the 4 over x to the 5th. Or in other words, you have 3x to the minus 5 plus 1 over x. The antiderivative of that is actually just following similar rules to up above, where you're going to say, okay, well I need x to the negative 4, raise the power by 1, but divide by negative 4, so I'm going to have negative 3 over 4, x to the negative 4, plus the natural log of x. And since we're dealing with only positive numbers, I don't need an absolute value, and I'll put plus c. If you're not 100% sure, take the derivative of it and see that you end up with what you started with.